Okay, AP Calculus, mean value theorem. This is example number 2. And we take this function. The first thing I look is this function. Is this function continuous everywhere on this function? Because remember, the function has to be continuous and differentiable everywhere. And we see that this function is not differentiable and is not continuous at x is equal to 0. But if we look here, the function 0 is not inside our interval. So we are able to use mean value theorem here, I believe. So I'm going to set this thing up. And remember, mean value theorem says that we're going to take f of b minus f of a over b minus a. And that's going to give us that slope value that we're looking for. So as we do that, we're going to take, make sure my f is correct, f of 2 minus f of 0.5 over 2 minus 0.5. And that's going to look like this, I think. I'm going to move this over. And that's going to look like this. That's going to look like 3 halves minus 6 halves. I'm just making that easier for myself. Over 3 halves. And if you do plug this in, you're going to get this math back yourself. And is all equal, again, in this case, to -1. And it's the same as the problem above, but that is a coincidence, I assure you. So don't draw any conclusions there. So this is that value. This is that slope value that we're looking for the line tangent in parallel. So here we go. So from here, supposed to take the derivative of the function, and I actually did that on the side. I used the quotient rule. So hopefully you were able to use the quotient rule. This is not what I'd be writing to my AP reader, but I did use the quotient rule here. And as I simplified it out, I found that f prime at x was equal to the opposite of 1 over x squared. And remember here, and this is what I do want my AP reader to know, that I realize that I'm supposed to set f prime at x equal to whatever that value is, in this case, -1. So that's the value I'm looking for. I'm looking for f prime at c. F prime at that value is going to make that happen. So I will set that equal to -1. As you saw, you can solve by multiply both sides by -1, and you get x squared is equal to 1. So at first, yeah, and you have to be careful here because it's a trick both ways. I am going to take the square root of both sides, so take the square root here and here, and get x is equal to plus or minus 1. Now, I'm not going to call this a guaranteed value because I'm going to be really smart. I'm going to take my time. I'm going to go back in here and ask myself, are both of these values inside that interval? Because if they're not, only the number inside that interval is the guaranteed value. So we look here, -1 is not there. So our guaranteed value is x equals +1. I always tell everybody, when you're writing to your AP reader, you don't have time to hug them and show them all your details, but you have to have time to hold their hand. So make sure that your work demonstrates what you're asked to do. Make sure that you're showing your calculus. So I hope this was really helpful for you. If it was, great. If you haven't already subscribed, please subscribe, and your comments are always welcome. Thanks so much.